variable on both sides. So when we have a variable on both sides of an equal sign, we're going to move the variable to one side by adding or subtracting. Now, what we're going to do with the remaining is we're going to have a two-step equation by first adding or subtracting, and then multiply or divide. So let's look at some examples to show this. Example 1. The temperature in a town is 32 degrees and falling 2 degrees every half hour. In another town far away, the temperature is 18 degrees and rising 1.5 degrees every half hour. In how many hours will the temperature be equal? So, right, we have two different towns that are eventually going to have the same temperature, and we're just going to figure out in how many hours will that be. So, let's set up our problem. We have the temperature in a town is 32 degrees and falling 2 degrees every half hour. So we're going to need a variable, and it's going to be in regards to the hour. So it's either an h, or we can put it as an x for a variable, but we know we need to have a variable. So we write this out. So we have 32 degrees, and then it's going to be falling every 2 degrees every half hour. So we're going to go minus 2, and let's just go for h for the half hour. Now, let's think about this just right here. So if we had 2 half hours, so 1 hour, so h was 2, so that means h is 2, so 2 times 2 is 4. That means in a 1 whole hour, 32 minus 4 is 28 degrees. So in that town, in 1 hour, it'd be 28 degrees. So that's kind of how it works with the variable, and that's why it stands there. Now, we're going to have an equal sign, and it's going to be equal to the other town. So it's going to be 18 degrees, and it's rising. So that means we're going to need to have a plus sign because it's rising. And it's rising 1.5 degrees every half hour. So we're also going to write an h. So if h was 2 again, and then 1.5 times 2 is 3, so then it would be 21 degrees. So maybe on the left it's 28, then on the right it's 21, so it's not equal yet. So we have to find what h is in order to make these both equal, which is the temperature when they're equal, right? And what hour that is. So now we've actually set up our problem. So now we can begin to solve. So our first thing will be is to move the variable by adding or subtracting. So I like to do the one that is the lesser of the two numbers. So 1.5 is much greater than negative 2 because of that negative sign, right? So we're going to go ahead and do the opposite of negative or subtracting of 2h. So we're going to add 2h on the left, and whatever we do to the left, we do to the right. So we just add 2h. Now this just becomes negative 2h plus 2h. Well, that's just 0. Then we can go ahead and bring down the 32 equals, and then 18. Now 1.5 plus 2 is then 3.5h. So we have 32 equals 18 plus 3.5. So what's our next step? Well, our next step would be is to get rid of the number on the right-hand side. So we have to do the opposite. So this is positive. So we're going to go ahead and subtract 18 on the right. And then we have to do it again also on the left. Because whatever we do to one side, in order to balance it all out, we have to do it to the other. So then this just becomes 0. And then on the left-hand side, we have 32 minus 18. Well, we can go ahead and borrow this 2. This becomes a 12. We can borrow a whole 10. So 12 minus 8 is 4. 2 minus 1 is 1. So now we have 14. Or we write it 14 equals 3.5h. Now, in order to get h all by itself, we're just going to go ahead and divide this by 3.5 on both sides. Because this just becomes a whole 1. So now it's just 1 times itself is just the variable, which would be h. So now we have 14 divided by 3.5. So let's get our calculators out. 14 divided by 3.5, and we get 4. So we have h is equal to 4. Now this is for half hours, right? We set up for the problem to be every half hour. And what's our question? Our question is in how many hours will the temperature be equal? Well, for every hour, there are 2 half hours. So we can just go 4 divided by 2, and then we get the answer of 2 hours. Now, if you aren't quite sure how this works out, let's just write. It's really a dimensional analysis problem, which we'll do later on. So we have 4 half hours, because that's what we solved for in the actual problem. We're going to need to know that there's 2 half hours, right, in 1 hour. This means, right, the same thing. We're just multiplying it essentially by 1, except we're changing what it's out of. So now it's out of hours instead of half hours. So we can go 4 times 1/2, which is equal to 2 hours. So that's how we solve for it. Or we can think of if you had 4 half hours that passed, so if you line them all up, that would be 2 hours. So either way would get you to the answer if you can think about it, or if you need to also do the math to make sure you are right. So now let's do one final example. Example 2. A town's population is 23,600 and it is decreasing by 125 people every year. A nearby town's population is 17,500 people and it's increasing by 180 people per year. In about how many years will the population of the towns be equal? So let's kind of set up this problem. So it's kind of similar to the last one, but instead we're dealing with population, right? So if we look at the first town, right, we have 23,600 and it's decreasing. So that means we're going to be subtracting this by 125 people every year. And what are we asking again? In about how many years will the populations be equal? So that means we're starting out with a population of 23,600. We're decreasing, so that means subtracting 125 people every year. So year is going to be our variable. So we're looking at what does y have to be in order for these to be equal. Now we need to do the other side so we know what we're trying to find. So we have another population of 17,500 and it's increasing, so that means adding 180 people per year. So we're doing the variable with y. So we're looking at what does y have to be for these to be equal. So let's go ahead and set this up. So our first step is to move the variable. So let's go ahead and move this one because this is the lesser of the two. So to undo subtraction, we go ahead and add. Now, whatever we do to one side, we do to the other. So here we have, now this just becomes 0. And then we have 17,500 just brought down, plus, because this is just going to be two positive numbers, so it's just going to be increasing. 0 plus 5 is 5, 8 plus 2 is 10, carry the 1, so that's a 3. Don't forget the variable. And then on the left, we just go ahead and bring down this number. So our next step would be to go ahead and get this 305y by itself. So in order to do that, we're going to go ahead and subtract on both sides this 17,500. So this just becomes, right, 0. Now we have 23,600 minus 17,500, and we get 6,100. So let's go ahead and bring that down, which is equal to, and then we'll just bring down this 305y. Now, what's our next step? Well, we need to get y completely by itself. And this really just means multiplication. So to undo multiplication, we go ahead and divide on both sides by the 305. So 305 divided by 305 is just then 1. Now, let's pull up our calculators, divide this by 305, and we get 20. So, this is equal to 20. So when, in 20 years, these towns will be equal.